Okay, so now it's on. Good morning, everyone. And thank you all for coming. My name is Seemann, and if you want to know more about me, there's information there on blog.plur.dk. And also I'm on Twitter at Plur, so you can follow me there. And what I'm going to do today is I'm going to try to answer a few frequently asked questions. And the talk is going to fall in 3 parts. So in the first part, I'm going to look at one frequently asked question and try to talk about why does it make sense to ask that question. But then I'm not going to answer the question yet because we need some more knowledge before we can properly answer that question. So that's part 1 of the talk, just establishing what's the question. Now in part 2 of the talk, I'm going to pose another frequently asked question and start to discuss, why are people asking that question and what can you do about it? And then I'll try to answer that question. And then in part 3, we're going to go back to the original question from part 1 and try to understand now we have enough knowledge from part 2 so that we can start to address the question from part 1, and that's going to be part 3. So the first frequently asked question that we will look at here is how do I combine dependency injection with async and await without leaky abstractions? So that's the hard part. If you don't add that qualifier, it's not that hard, and we'll see in a little example of that. So basically what I'm going to do here is I'm going to just walk through a lot of code and just show you what it means when we actually write code and the rubber meets the road. And I'm going to need an example scenario for that. So I have one that I keep coming back to over and over again and rewrite that lots of times, and that's the scenario of having to develop an online restaurant reservation system. It's one of those things where you want to make a restaurant reservation, so you find a form on a website or something like that, and you fill in the details about the reservation you'd like to make. You press the submit button, and the UI creates a little JSON document that it posts to an HTTP endpoint somewhere. And the code that we're going to look at is the server-side code that receives that JSON document and makes decisions about how to proceed. So the first thing we're going to look at is actually not the boundary where we receive the JSON document, but the core domain logic or the business logic, if we will. So I'm going to start just talking a little bit about the method signature itself here. We have a method called try_accept, and I will fill it out with some code, but I just want to spend 1 minute talking about the method signature itself. So you can tell that it receives a reservation object, and that's just a DTO that contains the data from that JSON document. So that is the name, the email address, the date, and the quantity. So it's just those 4 pieces of information. And then you'll notice that it returns a nullable int. And what's that int? Well, it's a reservation ID. If you have a reservation ID, you have a reservation. And you can use that reservation ID to further manipulate the reservation. You can change the reservation, you can cancel the reservation, and you can do things with the reservation in general. Now, if you don't have a reservation ID, that means you don't have a reservation. So if you get null back, that means, unfortunately, we couldn't accept your reservation. And there might be reasons for that. We'll look into that next. Now, if you're doing dependency injection, you might have injected dependencies into the class where try_accept sits on. So we might, for example, have injected a repository and just made that available via a read-only property like this. So normally this would arrive via constructor, so in constructor injection. But since this is 2019, I assume that people know how constructor injection works. So I'm just decided to save a little space and not actually show the constructor. But this arrives via the constructor and is now available as a read-only property. So since we have a repository, we can now go and query it. So we can say, give me all the reservations for that particular date. Once we have those, we can create or calculate the sum of all the quantities of those reservations. That gives us a number of reserved seats. And if we also know the capacity of the restaurant, we can now make a decision. So we can say, if that capacity is too small compared to the number of reserved seats we already have, and the new requested quantity, then unfortunately we're sold out, or we're so close to sold out that we can't accept the reservation. And that's the reason why we might decide to return null. So we have to reject that request. Otherwise we can move on, and finally we can call repository.create, and that creates or persists the reservation in the repository. And the create method returns an int, and the int just gets converted into a nullable int. So this point, there's no async and await stuff going on. I'm just trying to establish, what would it look like just without async and await, and then we can see how async and await, tends to add leaky abstractions as we go along. But let's just complete the example here. So if you're doing a little bit of domain modeling, maybe you say, well, okay, so that try accept thing looks like it's a concept. So maybe we can amplify that by defining an interface called iMaitre-D. So maitre-D is they're basically just French. It means the head waiter. That's typically the role in a restaurant that makes decisions on whether or not to accept the reservation. So a little bit of domain-driven design here. We're adopting the ubiquitous language of the domain that we're working in. So if we have a maitre-D interface like this, we can use a dependency injection again. So we have a post method on a reservations controller sitting somewhere, and this is the method that's actually going to receive the JSON document already encoded in the reservation DTO, and then it's going to return some sort of action result. And exactly what that action result is, it's not really important. We don't need to know the details of that, but that will be some sort of HTTP response. So if we have an injected maitre-D, what we can do is we can basically delegate most of the work to the maitre-D. We can call try accept. We get a nullable ID back. The only thing we need to figure out now is to say, well, what sort of HTTP response should we return based on whether or not we get null? So we can just check whether we have null, and if I get a null response back, I'll just return internal server error. This is a little helper method that returns one of those action results, and that represents a 500 internal server error HTTP response saying, sorry, table is unavailable. Now, I've had this discussion with people who've seen this talk before that says internal server error is not the appropriate thing to do with REST here. So if you think that that's the case, just imagine that it's another response. It's not really important. I'm sort of getting the impression that some of the criticism that has been raised against using internal server error is actually correct. So, but I didn't want to change the slides. On the other hand, if we do have an ID, we just could return that ID. So I just have another helper method that returns an action result that represents 200 OK. And notice that in that case, I take the ID value, so the actual integer, the actual reservation ID, and I put that in the HTTP response body. So that's the contract that I have with all of my HTTP clients. I'm going to do quite a bit of refactoring of this sort of behavior over and over again, but I have to preserve that overall contract with my HTTP callers that if I return 200 OK, the reservation ID should be in the response body. So that's my contract. So at this point, there's no async and await going on, but if you look at the reservations repository here, this was developed by figuring out what the try accept method needs. So we injected a repository into try accept, or the method or the object that try accept sits on, the maitre-D, and then I basically just developed the algorithm or the implementation, and then I figured out what it needs in order to do its job. So this is known as the dependency inversion principle, meaning the client gets to decide what the API of the dependency looks like. So that's the dependency inversion principle. It's one of the 5 solid principles. So far so good, and it means it looks like this. But then you look at it and you say, well, but really, my implementation is I'm talking to a relational database. So I'd like that to be asynchronous because that might be more efficient in terms of server resources. I'd like to make my implementation asynchronous. And in order to do that, you have to change the types. Instead of returning just normal types, you have to return tasks. And we've now introduced a leaky abstraction. An implementation detail is leaking into how the abstraction is defined. This is no longer the dependency inversion principle. This is the implementation that gets to decide what things look like. This is the definition of a leaky abstraction. And then you can say, well, yeah, but okay, fair enough, but who are we really kidding? We call it a repository, but everyone understands that it's a database, so okay, is it really that important? And I may be able to, I may buy that argument and say, okay, fair enough, a repository represents some sort of out-of-process resource, so I can accept the argument that needs to be asynchronous. Okay, let's just move on and see where this leads us. Okay, I buy the argument, fair enough. So going back to the try accept method, which is the one that consumes that repository interface, in order to make things work now, I have to add async and await keywords. It's not a big deal, it's just a few things that we have to add, so that's not so bad. I also have to change the return type to a task. And this means I also now have to change the return type of my interface definition in iMaitre-D. Now at this point, this annoys me because I can buy the argument that a repository is an out-of-process resource that needs to be asynchronous. Okay, fine, I buy that. This is a domain concept. Why my business decision logic has to be asynchronous is not clear. There is nothing in the concept of making a business decision that says this has to happen asynchronously. But for technical reasons, it does. But conceptually, there's no reason for that. So I find this annoying. But we can move on and look at the post method. We just have to add a wait on that as well now, because try accept is asynchronous, and that means we also have to add async and return a task. So, so far so good. Now at this point we're basically done, because most web frameworks nowadays understand asynchronous programming, so that's good. So we're done. And what I've shown you here is basically a conclusion that other people have reached a long time ago. If you want to be async, you need to be async all the way. So nothing new in this, and this is not the point of the talk. This is sort of like the premise. And people will tell you that that's just the way it is. There is no other way. And I always look up when people say categorical statements like this and say, okay, really? I just have to come up with one counter example that proves that there is another way, and then I will have disproven that assertion there. And I can do that. Now, to be clear, this is the end of part one of the talk. We've now established what the problem is. I'm going to put it aside a little bit and start talking about something else. But ultimately, I'm going to show you another way. And I want to be clear that the other way I'm going to show you, I make no claim that that other way is better. It's just another way. And personally, I feel that sometimes just using async in a way that, like I just shown you, that's perfectly fine. It's a little bit of a compromise, but it's easy, and you just have to sprinkle on some async and await, and then all is good. In other cases, I actually believe that what I'm going to show you next is the better option. But I'm not even on one side or the other side of that fence. It depends, like all good decisions. So the point of the talk is just to inform you that there is an alternative, and now when you're aware that that alternative exists, you can make a proper choice. If you only know one way of doing things, you have no choice. If you know more than one way of doing things, now you have a choice. So that's the point. All right, so I'm going to put this problem aside a little bit, and I'm going to start looking at another frequently asked question, and that is, how do I get the value out of my monad? Now, I'm not going to assume that you know what a monad is, so we'll get back to that in a little while, but in short, the answer to this question is mu. So mu is, this character basically means something like null, void, emptiness, something like that, but there is a tradition in Zen Buddhist philosophy that interprets this word as meaning unask the question. And if you want a Western perspective on this whole Zen Buddhist philosophy thing, then you could do worse with your time than reading Zen and the Art of Motorcycle Maintenance. But since you're programmers, you probably rather want to read Gödel, Escher, Bach, because that's actually written by a computer scientist. But it also talks about the same idea of unasking the question. We see that a lot when people are trying to learn new things, particularly in information technology and programming. There's a related problem called the XY problem, which is so common on Stack Overflow that Stack Overflow has a fact about that. Basically, it occurs when people are trying to learn new things. So learning a new programming language, learning a new library, learning a new framework, whatever it is, we see this happening a lot. And the way to explain this is that we could say, you're trying to learn something new, you're trying to learn a new way of doing things, and you're trying to accomplish a goal, and we'll call that goal Y. And based on your knowledge about other things that you already know, you form a plan for how you want to accomplish your goal. And that plan involves a series of steps. Well, one of the steps, we can call that X. You're stuck on that step. You can't figure out how to do X. And you think, if I can just figure out how to do X, I know how to do all the other steps, and that will enable me to accomplish my goal Y. So you go on Stack Overflow or somewhere else and you say, how do I do X? And then you're met with a barrage of, why do you want to do X? That's stupid, quit asking stupid questions or whatever people say on Stack Overflow. But if you manage to find someone who's actually interested in engaging in a real dialogue with you, together you may be able to flush out that you're really trying to do Y. And as soon as the expert that's trying to help you figures out that, oh, you're really trying to do Y, okay, in that case, you should do Z, and the Z will enable you to do Y. The other thing makes sense, where you come from, but in the new thing you're trying to learn, that's just not a thing at all. There's a completely different way of approaching the problem. So this happens a lot. Now, this happens a lot when people are starting to look into functional programming in statically typed languages. So we can what I've tried to do here is I try to boil down all sorts of detailed questions into this common question, how do I get the value out of my monad? Because it often boils down into that. And the short answer is that you don't. But I haven't told you what a monad is, and I'm not assuming that you know what it is. So we'll just briefly cover that. I think I can do this in about 10 minutes. So in short, a monad is a functor you can flatten. And you go, okay, fair enough, what's a functor? It's not really helpful. So we'll have to start with just defining what a functor is. And once you understood what that is, the monad is actually pretty easy to understand once you understand what a functor is. And a functor is not that hard to understand. So monads have been made into this scary thing that it doesn't need to be at all. It's pretty straightforward actually. So a functor is a data container. It's not a Docker container, it's not a dependency injection container, it's not a shipping container, it's just a data structure that contains values, if you will, or other data. So we can imagine that we can draw it as some sort of rectangle here. So this would be some sort of data type that's generically typed, so it's a container of other objects. So it could be foo of t, and that would be a container of things of the type t, generically typed. And in order for a data container to be a functor, it must support something we call a structure-preserving map. And that means we can translate all the data that's inside the container, and the return value of making such a translation is a new container with all the contents translated. So this seems a little bit abstract, so let's put some examples in. So the simplest example of a functor is some sort of collection. So this could be a list of t, enumerable of t, an array, whatever. All of these things together is just the list functor. That is an example of one type of functor. A functor is a much more abstract idea. So a structure-preserving map could be something like this, where you say, well, let's just add 1 to each of those numbers, and now I have a new collection with some other numbers. But since it's a generically typed container, we don't have to stick to numbers. We can translate all the numbers into strings, or we could translate them all into Boolean values. So this idea about this translation being structure-preserving, it depends a little bit about what the container is, what the functor is, what the structure is. But for collections here, it's something it relates to the size of the container. So you'll notice the input container there has the size of 6 elements. So all the outputs also have the size of 6 elements. And the order of all the output collections here is determined by the order of the elements in the input collection. So that's why, particularly on the third example there with the Boolean values, that's why it says false, 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 true, true, false, and not in some other order. And you could also say, well, why do we need to have all of that repetition? Because there's, only 2 values, true and false. Why don't we just collapse them? Well, because this is not a set operation. This is just a translation of collections, and we preserve the structure of the original container. So that's what it means to have a structure-preserving map for collections. And I'll talk about what it means for other functors in a moment. Now, one thing we'll also notice is that the output of such an operation is itself a container, and that means we could use that as an input for another step, so we can now, compose things together like that. And if we want to see what that looks like in C#, for example, we could start by creating an array. It doesn't have to be an array, but I will tend to use arrays throughout this talk because that's just the tersest syntax in C#. But this could also have been a list of t or something else. So here we have an array of numbers. The structure-preserving map in C# is called select. Most other languages call it map, but for reasons, it's called select in C#. So here I just take, for each of the elements, I just add 1 to those elements, and the output of that is a new type of collection, and I can do a second step and turn them all into strings like this. And now I have, an array of strings. So if you look at something like this, you'd say, well, okay, so this is a functor, turns out also to be a monad. And then you look at this and you say, well, why are people asking that question? How do I get the value out of my monad? Because it's pretty clear that if you understand that this is a monad, we'll get back to what a monad is in a moment. It seems fairly clear that it's not really a sensible question to ask, how to get the value out of my array. Because, okay, which value? The first one, the third one, the last one, what are you talking about? You have to be more specific than that. And what do you want to do if the array is empty? You know that an array might be empty, so the value is nonsensical. It doesn't make any sense. You have to say which value do you want and what do you want to do if the array is empty. At least you have to tell me those things. So people don't ask that question, but on the other hand, most people don't realize that using select like this, that you're actually using a list as a functor, because the Microsoft documentation doesn't tell you that, for reasons that I've never really been able to understand. So I believe that when people encounter the concept of functors and monads for the first time, they tend to encounter it in other contexts. And often they encountered it in a context where I call them unit containers. So there's a subset of monads that have this extra quality that they are containers of exactly one value. Now, unit container is just my terminology. One example might be lazy of t. This has been around in .NET for a decade or more. And this is a lazy computation. It is guaranteed to contain exactly one value of the type t. It's just lazily computed. So in the .NET, in .NET itself, it's not a functor because it doesn't have a select method, but we can add one. We can add a select method as an extension method that turns a lazy of t into lazy of t result, and the implementation is basically just a one-liner. I'm not going to dwell too much on the implementation. I'd rather talk about how you can use such a thing. So what I can do here is, as an example, I can create a lazy of int, and even though you'll notice that there's a thread.sleep here that will block the thread for 10 seconds, now that lazy of int, all this expression, it completes immediately because it's a lazily evaluated computation. And what I can do now is I can transform my lazy of int into a lazy of string using my new select method, and that still completes immediately. If I want to get the string out of y, I can force evaluation by going .value, and at this point it's going to block for 10 seconds. If I do it a second time, it's just going to complete immediately again because lazy of t remembers the value once it's evaluated it once. So that y variable, that lazy of string, behaves exactly like you'd imagine or how you'd expect a lazy computation to behave. And that means that select projection there preserves the invariance or preserves the expected behavior of what it means to be a lazy computation. So that is a structure preserving map. So that means lazy of t is a functor. We just have to add that select extension method, and that makes it a functor. And not only can we do that with lazy of t, we can do that with task of t as well. As you can tell, the implementation is a little bit different, but we can walk through a very similar example here. Creating a task of int completes immediately, even though the task starts to run on a background process. If I want to turn my task of int into a task of string, I can now do that with my new select method, and that still completes immediately. Only when I await the value will it block for whatever time is left from those 10 seconds that it's going to delay. If I await the variable once more, again, it completes immediately because, like lazy of t, task of t also remembers the result once it's calculated at once. So again, all the things we'd expect from a task of string is true, even though we've made that projection. That select method preserves the invariance of what it means to be an asynchronous task, and that means it's a structure preserving map. It preserves the structure of what it means to be asynchronous. So that's a functor as well. So not only is lazy of t a functor, task of t is a functor as well. So you'll notice that I've written, the select method call using method call syntax, but I could also have written it using query syntax like this. So normally when people see query syntax, if they use it at all, they think of it as being something related to IEnumable or maybe iQueryable. In this case, if x is IEnumable of int, then y is inferred to be IEnumable of string. But now that we have those select methods for lazy of t, that means this syntax actually also works for lazy of t. So if you have a lazy of int, you can turn that into a lazy of string using query syntax. And the same thing is true for task. So this might be a little bit surprising that you just have to add the select method, and then this syntax is now all of a sudden available to you. It wasn't before, but by adding the select method, it becomes available. And you can do this with your own custom types. And you say, wow, what is the magic that makes this happen? Well, the magic that makes this happen is because the C# team designed that language feature around the concept of a functor. So basically they said, well, if the type looks like a functor because it has the appropriate select method, then this syntax will compile. So the C# understands functors, and it understands monads as well, actually. So we haven't talked about what a monad is, so that's the next thing. It's a functor you can flatten, and then you go say, well, what does that mean? When is a functor not flat? So I'm going to show you a couple of examples of that as well. So we go back to lists first, and then we're going to look at tasks in 2 minutes. So a string like this one here has a split instance method. So you can use this method to split a string on the comma, for example, like this one, and what you get is an array of strings. What if you have an array of comma-separated strings like this one, though? Now, if you go select on that one, you say, well, I'm going to select each of the strings and I'm going to split them. In that case, you're going to get a nested array. You get an array of strings. And that's not always what you want. Sometimes you just want a flat list. So there's another method you can use for that. You can use select many. And if you use select many, you get a flat list. So why is it called select many? I believe the reason for that, I haven't any authoritative source on that, but I believe that the reason for that is that when you're doing a select, what happens inside that lambda expression produces many values, because split produces many values. So you're doing select, and you're selecting many values, and then you're flattening as you go, so that's why it's called select many. That's my theory anyway. But you notice that it enables us to flatten as we go. And that capability, this method select many, that's what turns a functor into a monad. If your functor can do this also, then it's a monad. That's basically what it means. There's a little bit more to it, but that's the intuition you need. That's basically all you need to know. Now you understand what a monad is. So what about something like task? Could they be nested as well? Well, yeah, here's a task of int. Here's another task of int. What if I wanted to add them together? I want to use my new select query. I can try to do that, but the result of that, z, turns out to be a task of an int. So that's a nested task. How do I get the value out of that? Well, you can actually do this, await z. That's a little bit odd. I was a little bit surprised when I discovered that you can write stuff like that, but you can. But imagine that you nest tasks even further, and then you'd have to go await z. So that seems a little bit clunky. That's not really the nicest way of writing code. So can we flatten as we go? Yes, we can. We just need to add a select many extension method to task with t, and I'm not going to show you what it looks like. You can Google it. It's pretty straightforward, or it might be a good exercise. But if you add a select many extension method, you can do that, and then we're flattening as we go, and then z is just a normal unnested task of int. And once you've added that select many method, you can also rewrite the same query in query syntax, and now most of the async and await keywords actually disappear, and you can just have this sort of Cartesian, combination of things happening here. So that works as well. So task of t is a monad, just like lazy of t. You can do the same thing with lazy of t. That's a monad as well. Right, so there's definitely a subset of monads where it makes sense to ask the question, how do I get the value out of my monad? Because you can, for lazy of string, you just have to go dot value. And the same thing applies to, task of string. You can await it. You see this in other languages as well. We have something very similar in F# called async of string, that you can also, get the string out of it by running the asynchronous computation. Even Haskell has quite a few of those unit containers. Simplest one is one called identity, but you can get the value out of those containers if you'd like to. So this is a concept that pops up in many different languages. So these are not all monads. These are just some monads. These are the containers that I call unit containers because they're guaranteed to contain exactly one value. And for that subset, it makes sense to ask the question, how do I get the value out of it? But where I think it really starts to break down for people is when you run into what I call semi-containers. So these are containers of data that look like they contain a single value, except for the cases where it doesn't. So it may or may not contain a value. And you probably know nullable of t. This is, again, has been around in .NET for many, many years. So with nullable of t, what people often do, what you've seen an example of before, is you have some sort of nullable int, for example, an ID, and then you start checking, is it null? If it's not null, I know it's safe to access id.value. In this case, value is a customer ID, and I can create a new customer out of the customer ID. But you'll notice that it says return here. So this little code snippet is something that sits in a larger method that returns a customer. That's basically what we can infer from this. So if we want to return a customer, we need to also tell the compiler, okay, what do we do if ID turns out to be null? There is an else branch. You must deal with this, otherwise your code will not compile. And then people go, I don't know what to do. I'll throw an exception. And if you write code like this and encapsulate this in a little method, now you have a little method that says, get customer that returns a customer, and then the next thing, I come by and I say, oh, this is a method that returns a customer. I'm going to call that, and I'm going to start, interacting with the customer that I get as a return value. Hey, all my code compiles. That's good. Let's put it in production. And then once I put it in production, half the time it's going to throw that exception because I didn't realize that that was the case. So if you structure your code like this, you're basically just putting out a minefield where your code is just waiting to explode at runtime at various different cases. So it makes the code really hard to maintain and understand what's going on there. So don't do that. That's a bad way of structuring code. But then the problem is, okay, then what are we supposed to do? So let's look at that. Okay, it turns out that functors might actually help us. So we can make nullable of t a functor with some constraints, however. The constraints are that t, that's the input generic type, and t resolved, that's the output generic type, must both be structs. They must both be value types. And the reason for that is that nullable of t itself has that constraint on the type definition that t must be a struct. So within that subset of all types in .NET, though, nullable of t is still a functor. So you can write code like this. You can say, well, I can translate a nullable of int into nullable of bool because they are both value types. So that works. This compiles. And then you look at the code and you say, oh, that's nice. There's no checking for null. There's no if-else branch. All that stuff is just hidden away inside that select method. That's really neat. So I could just go on and do select, 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 and just stay inside that nullable little world. That's nice. Can I do something similar with my customer ID then? Could I do something like this? That would be nice. And unfortunately you can't because this doesn't compile. And it doesn't compile because t and t resolved must be a struct, and customer is not a value type. That's a reference type, so therefore it doesn't compile. But then maybe you're a little bit interested and you say, well, it'd be nice if we could. Could we somehow lift that constraint from nullable of t and saying, well, what if t doesn't have to be a value type? What if it could be anything? That'd be nice. But we can't change nullable of t, but we can introduce our own generically typed data containers. So let's write one called maybe of t. Some people call this idea maybe, some people call it option. It's the same idea. So various different ways you can implement this. Here's the simplest one that I can easily illustrate. We have a flag called hasItem, and then we have the item itself, and then we have two constructor overloads. The first constructor doesn't take any inputs, so it just sets that flag to false. hasItem is false. Item itself is undefined. It is uninitialized, so we don't know exactly what that is. In this case, it's not safe to try to access the item. There's another constructor overload that receives the item as an input argument and sets the flag to true, which basically means hasItem is true, means the item is now initialized, it is safe to access. So this is a generically typed data container. We can make it a functor by making sure that there's a select method. So far you've seen me do select methods as extension methods, but it can also be an instance method. So we can just put it as an instance method on maybe of t, and it basically looks like this. So you'll notice that this is an instance method on maybe of t that returns maybe of t result. And the way that we implement that is basically just looking at that flag. So if hasItem is true, that means the item itself is initialized and it's safe to access it. And since this is an instance of maybe of t, the type of item is t. And we have this little selector coming in through the argument, which is a function that translates a t into a t result. So since we have a value of the type t, we can call that selector function, and that produces a value of the type t result. And then we can use that to populate a new maybe of t result by calling that constructor overload that takes a t result value. And we return that. Else, we just return an empty one. So that's pretty straightforward. This preserves the structure. This is a structure preserving map because it takes populated maybe of t values and turn them into populated maybe of t result values. It takes empty maybe of t values and turns them into empty maybe of t result values. So it preserves the structure of what it means to be a maybe of t object, if you will. So this is a functor as well. Maybe of t is now a functor. And we can make it a monad by also creating a select many method. And I'm not going to spend too much time talking about the select many method because we're not going to use it that much, actually. We're mostly going to use the functor. So before we return to the async dependency injection example, I'm just going to show you another little example about how this composes in a very nice way. So what we can do is we can create a little wrapper, a little helper around this idea of trying to pass a string into an integer. And you could say, well, but that capability already exists. We can do, int.tryPass. But again, with the API that you're given by .NET itself, you again run into this problem that you say, well, you sort of need to branch, and you say, well, okay, if you find an integer, that's fine, but what do you do in the else branch? And in this case, it's clear because we can return a populated maybe of int if we can pass the integer, and we just return an empty one if we can't. So instead of having to rely on throwing exceptions or returning null or something else, this is always safe. Whatever happens here, what you get, you actually get a real object back. You never get a null reference exception or anything from using an API like this, and it composes. So we can do the same thing by trying to pass a date time, for example, and it's entirely the same template that we sort of apply to this sort of implementation. And I'll show you how this composes. So imagine that you have to write an application that services some sort of car rental organization. So you start by asking the user, you have a little method called collectDate, and when you call collectDate, it poses the question to the user, please enter the date from which you would like to rent the car. And the user types in a date, and that's a string, and then you call tryPassDate with that string, and you get a maybe of date time. And then you ask another question, you call collect number of days, and it says to the user, please enter the number of days you'd like to rent the car, and the user enters a number, and that's a string, and then you pass that string to tryPassInt, and you get maybe of int back. And you probably ask a lot of other questions, and you sort of gather a lot of information in that way. And now you want to compose all of that information into a contract, because you have a contract object that can calculate prices and so on. So you start by, we can use query syntax for this. So we'll create a maybe of contract, and we'll start by saying from D and MD. So that D is a datetime value if it exists. If this code runs at all, that will be a datetime value. From I and MI, that I will be an integer. And we can keep on going like that. So if all those maybes are populated, our maybe of contract will also be populated. If just one of them are empty, then that maybe of contract will also be empty. So this is a pretty easy and standardized way of doing data validation. There's a little bit more of a sophisticated way of doing that, but it gets things done in a pinch. So far, so good. But then what often happens is people say, well, okay, but I have this contract, and the contract has some methods where I can call to calculate the price, and I want to show a quote to my user, my potential customer, so that they may decide to rent my car. I need to get, I need to get the contract out of the maybe. Well, how do I do that? And people try to do something like this, where they say, okay, if MC has item, I'll try to access the item, and then the item is a contract, and then they can call calculate price. Yeah, but that does not compile, because I've very deliberately designed my maybe API so that that doesn't work. Because you're not supposed to do this. Again, this this style of programming is brittle, because what happens if has item is false? Then what's going to be the value of Q? Is it going to be 0? Do you want to run the risk of actually showing the customer a 0 price on the application they're interacting with? Or there could be all sorts of other issues that result from this style of programming. So you're not supposed to do that, and that's why I designed the maybe API so that this is not possible. These has item and item exist, but they're private class fields, so you can't access them from the outside, and that is by design. So if you're not supposed to do that, then what are you supposed to do? Well, we already seen that maybe of t is a functor. So you can just do a structure preserving map. You just say, well, let's just translate maybe of contract into a maybe of decimal by calling calculate price inside of it. Now this is completely safe, because if the maybe of contract is populated, that little lambda expression is going to run, and you're going to get a populated maybe of decimal. And if the maybe of contract is empty, nothing's going to happen. You're just going to have a maybe of decimal that's empty. It's not going to throw exceptions, and you also notice that there's less code to write. That means also there's less code to understand. So this basically generalizes, and this is the general idea, when working with monads. How do I get the value out of my monad? Well, you don't. You inject the desired behavior into the monad, which is exactly what happened here. I took, that calculate price, and I just kept it inside the select, inside the maybe environment, if you will. So I'm just going from one maybe value to another one, and as I go. And that's how you're supposed to work with functors and monads. And I know what you're thinking, or maybe you're thinking this. Yeah, but ultimately I need to produce a result, because I need to put something on the screen so that the user can make a decision. Sure, fair enough. Let's go back to collections for a moment. Now here, again, we have collections of numbers. And you could say, if you don't want to put all the numbers on the screen, if you just want to put a single number on the screen of the user, how would you do that? Well, that probably depends on how you want to produce that single number, but maybe you just want to produce the sum, and you can put this particular number on the screen. But sum is a very specialized way of reducing many numbers into one. Maybe you want to produce the product instead, and there's no specialized product extension method, but there's a general purpose method called aggregate that you can use. So the aggregate method, what that wants you to do is you have to supply a little function, a little lambda expression that says, well, given two values, in this case 2 integers, please reduce it to 1. And so that's that little lambda expression that says x comma y. And in this case, I'm just saying, well, I'm just going to multiply them together. So that takes 2 integers and turns them into 1 integer. And this just happens, then it takes that 1 integer that you just produced, and then it gives you the next one. And so it just, piecemeal reduces all the numbers into one number. But you'll notice that I'm using the overload here that takes a seed, and the seed is 1. And the reason for that is it's not necessary here, but if you have an empty collection, an empty array, aggregate wants to return an integer, or whatever you want to return, whatever type you want to return, but you can't return an integer from an empty array unless you tell it, what's the default value. So in this case, I'm just using 1, because 1 times something is just the other number. So this idea of taking a seed and a little lambda expression that we can sort of use to do projections, we can apply that to maybe of t as well. Now this one, by the way, returns 0 because one of the numbers is 0, so that's not so interesting. But let's take that idea and apply it to maybe of t. So we'll create another instance method on maybe of t. I'm not going to call it aggregate, I'm going to call it match for reasons that will become clear in a few minutes. But the idea is that this is again an instance method on maybe of t, and we will project as we go along, so we don't have to return a value of the same type t. We can project it to t result as we go along, but t result could be the same as t. Nothing prevents that. So how do we implement that? Again, this is basically just a one-liner. You just look at the flag has item, and if that's true, you know that the item is available, that has been initialized, and it is a value of the type t. And we have this little function sitting up there in the argument list called just. So if you're wondering about nothing and just, why they're called that, it's sort of by convention. That's what you normally call things with maybes. It's a little bit of an odd naming. But just is a function that takes a t value and returns a t result. So you can just call just of item and return that. And if has item is false, we fall on the other side of that ternary operator, and then we can just return the nothing value, which is also of the type t result. So again, this is one of those methods where if you supply all the appropriate arguments there, it is completely safe to call this method. It's never going to throw exceptions unless they're null, and then you will get those argument null exceptions. But apart from that, it's always going to work, and it's very, very simple to call, and you will know exactly what to do when you see the type signature. So now we can return to this question of how do I combine dependency injection with async and await without leaky abstractions. So this is part 3 of the talk. Now we have learned enough to see if we can address this question as well. So we left it off by this assertion that when you're doing asynchronous programming, it has to be async all the way. And then I said, well, yeah, maybe not. Okay, so let's see if there's another way of doing things. Well, we need to change things around a little bit. So the first thing I want to do is to move the impure operations to the boundary of the system. This is a common trick that you'll often, this is sort of like, you often hear, functional programmers having catchphrases, and one catchphrase is, make illegal states unrepresentable. You'll hear people say that all the time. And you'll also hear people say this a lot, move impure operations to the boundary of the system. Turns out to be a good idea in object-oriented programming as well. Basically, the idea is that, whatever interacts with the real world, whatever queries your database, whatever sends off emails, whatever, paints things on a screen, that's the operation that interacts with the real world. That should happen at the edge of the system. And we have an object-oriented architecture description called ports and adapters that talks about exactly that style of architecture. So this is a tried and true approach to object-oriented architecture as well. So what's an impure operation? I think it's easiest just to explain that by some examples, because we have examples of 2 types of impure operations here, and there are only 2 types, so we have examples of both. So read reservations here is impure because it's non-deterministic. In order for a function to be pure, a function must be deterministic, and that means if you call the function with the same input arguments, it should always produce the same output value. But when you do that with a database interaction, you can call the database with a particular set of input arguments, and you can get one result, and then you could do it 5 or 10 minutes later, and now you get another set of results because the state of the database changed in the meantime. We don't consider the state of the database to be part of the function. So from the perspective of our code, such an operation looks non-deterministic. So that means it's not pure. Another source of impurity is repository.create, and that's because it has a side effect. This would create a row in the database every time you call it. And pure functions are deterministic, have no side effects. So if one of those 2 things are not true, that means the operation is impure. So these 2 operations are impure for each their own reasons. So we want to move those to the boundary of the system. I don't want to get rid of them because these are absolutely necessary things in order to make the entire application do what it's supposed to do. But they shouldn't happen here. They should happen closer to the boundary of the system, or the edge of the system. So how to do that? Well, the first one is the easiest one, so we're going to start with this one. You'll notice that repository.read reservations, this always happens. This method call is always happening as the first thing, unconditionally. So you can say, well, okay, so why is it the responsibility of this try except method to make that method call? Couldn't we just say, well, the responsibility of this method is actually just to make a business decision? Why does it need to go and pretend that it's doing, interacting with a database? Couldn't we just make the data itself, the reservations, a prerequisite for, making that business decision? And then someone else might have the responsibility of actually figuring out where that data comes from. Because then we can also decouple ourselves completely from, how to produce that data. Okay, so we can do that. And the only thing we need to do is to, promote reservations to be a method argument. So that's pretty straightforward. But sometimes, things have to get worse before they get better. And one of the things that will get worse now is that if we look at maitre d', that interface from before, in order for things to still compile, we need to change the interface definition to also take reservations as one of the method arguments, because otherwise we can't implement that interface. And then if you say, well, that's a leaky abstraction if I've ever seen one, I would agree. This is a leaky abstraction. Now, this is only the first in a series of refactorings that I'm going to do, and trust me, when I'm done with all my refactorings, this is no longer going to be a problem. So let's just move on, and you'll see towards the end why this is not a problem. So we'll have to change the post method a little bit as well, and you've noticed we already injected maitre d'. We can just inject that repository as well, and that means we can start by calling repository.read reservations, and then now we have the reservations, we can call maitre d.try accept with those reservations, and the rest of the code is the same as before. Before we move on, I just want to remind you that the last part of the code here, it does exactly what I've talked about that you shouldn't do. You know, it gets the value out of the monad. You're checking whether the ID is null, and if it's not null, you go id.value. And it's possible to do this with a nullable of t, but when we change things around, it will no longer be possible. And we're not really supposed to do this. This is fairly simple code, but it can, you know, if it gets a little bit more complicated, this sort of a programming style starts to get, you know, brittle. So we should avoid writing code like this. So how do we get rid of, or not get rid of, how do we move repository create to the post method as well? Now this one is a little bit harder because this doesn't happen unconditionally. There's a branching instruction sitting a little bit above where, you know, if we decide that the remaining capacity is too little, we return null instead, and that means we don't call repository.create. So we need to figure out if we want to move repository create to the boundary of the system, we need to communicate to the caller the decision we made so that they can, you know, decide whether or not to call repository.create. So how do we communicate the decision to the caller? Well, we are already doing that because we're returning a nullable int, and we said the contract here is that if that is null, that means we didn't accept the reservation. If it's an integer, you have a reservation. But the integer that is being returned here comes from repository.create, and if I move repository.create, I will no longer have an integer. So I'm going to need to replace that integer with something else, and that something else may not actually be a value type. So in general, we have this constraint of nullable of t that it needs to be a value type or a struct. And if I want to replace that integer with something else that may not be a struct, I can't do that with nullable of t. But I can do it with maybe of t. So just as an initial step, I'm going to change my nullable of int into a maybe of int. And that's a fairly straightforward thing. So just if you pay attention to the top line, I'm just going to replace that nullable of int with a maybe of int. And then it causes me to do a few changes in the code. Instead of returning null, I'm now returning an empty maybe of int. Instead of just taking an int and relying on an implicit conversion from int to nullable of int, I now return a populated maybe of int that contains the ID. We'll move forward from this, but again, we have to change the maitre d interface definition. Now we have a maybe of int as the return value from calling maitre d.try accept. So how do we turn that into an I-action result? How do we turn that into an HTTP response? Now before, we were doing null checking, and then we were pulling the value out of the monad, or the nullable of t. We can't do that anymore because that's what I showed you just before. You can't check whether or not the maybe is populated because you're not supposed to do that. So what can we do instead? Well, we can use that match method. That was like the same thing as the aggregate method. And you'll notice that I'm just immediately going return m.match. So whatever match returns, that's what I'm going to return. So that must be an I-action result, one of those HTTP responses. So I'm going to supply some arguments to the match method, and I'm going to use named arguments so that we can see which is which. So in the nothing case, I'm going to return internal server error. That's an I-action result, and that basically means if we match on nothing, then we still return 500 internal server error. If we match on just, I have to supply a function, so I write this little lambda expression here that receives the ID, the integer, and just calls 200 with that ID. So 200 OK response still contains the reservation ID in the response body, just like we did before. That's the contract I have with my HTTP clients. So this is also the explanation of why did I call that method match? Because using named arguments like this starts to look like pattern matching. If you've ever seen pattern matching in F#, for example, this looks like the same idea. You match on nothing, and that is one thing. You match on just, that's another thing. Okay, so now we're in the position where we can move repository create to the boundary of the system. Now, if I take away that method call here, I no longer have an int to return, so I'm going to return a maybe of reservation instead. So an empty one to indicate that we didn't accept the reservation, and just a populated maybe of reservation with the original reservation inside to indicate that this is the reservation we accepted. And again, we have to change the maitre d interface, but we'll just move on and pretend that that's not an issue, because it's not. So now I have a maybe of reservation when I've called maitre d.try accept. I'm going to need an integer because I need to put that integer in a 200 OK response. So it'd be nice if I had a maybe of int. That's what I had before. How do I turn a maybe of reservation into a maybe of int? Well, maybe it's a functor, so I can just do select. So I can just do this. So I can call repository create here, and that's, again, this is going to run if the maybe of reservation is populated, and if the maybe of reservation is not populated, this is just not going to run. I'm just going to get, an empty maybe back. So now I have a maybe of int. Well, not quite. I have a maybe of a task of an int because that reservations create, method call here is actually asynchronous. So we actually have a stack of monads here, but it turns out not to be an issue, so we can just move on. So we still have maybe on the outside, and that means I can still call the match method. Now the match method has become a little bit more awkward to use because I need to return tasks from within that match method. So you'll notice it says task from result and so on. So it's not quite as pretty as before, but we'll deal with that. So it'll be pretty again in a few minutes. So let's not worry about that. So at this point, something interesting happens. If you try to compile, there will be a compiler warning. The compiler will tell you, this async method lacks await operators. And you go and say, yeah, it says async, but there's no await anywhere. So why does it need to be async again? It doesn't. Yes, let's get rid of that. This is what was bothering me all along, and now I've solved the problem. My business logic does not have to be asynchronous. Why should it have to be asynchronous? It's no longer asynchronous. Problem solved. I have to change the maitre d interface. The only change I need to make in the post method is that that await keyword that sits in front of try accept, that has to go away. But apart from that, that's the only change I need to make. But if I go back and look at the maitre d and the try accept method again, there's another thing that we may notice, and that is that repository dependency is also no longer being used. So we can get rid of that as well. So what we are left with now is pretty close to something we would call a pure function. It's not entirely pure because there's a little bit of state mutation going on there towards the end, but that would actually be fairly easy to also deal with that problem if you think that's a problem. But it's pure enough in the sense that it's deterministic. What happens inside the try accept method, the only thing that influences which path you end up taking through that method is just the input arguments and the capacity, which is just an input to the constructor. So we can completely control which path is being taken by the try accept method and what it returns by making sure that we supply it with the right arguments. So why are we having that maitre d dependency? And some people might say, yeah, but this is because it makes the code testable, because now I can create a stub of my maitre d dependency, and I can use a mocking framework to set up some expectations that that completely controls how try accept behaves. But then I say, well, yeah, if you use the maitre d object, you can completely control how try accept behaves because you just have to make sure that it receives the right input arguments. So we'll just do this. We'll just create the concrete class and get rid of that dependency. So that means that interface, you no longer have that dependency. And if you consistently remove that dependency from all your code, the interface is no longer required. You can just delete the interface and move on. We still have the capability, we still have the maitre d object, but now it just no longer implements the interface. And that, again, makes the code simpler. And maybe you think it's not so pretty to have that new maitre d sitting in line there. So why do we need to create a new one of those every time we need it? So we could just promote that to a little class field and do some other refactoring, and then the code might look up looking like this, which is much prettier. So at this point, you'll notice that we start by simply just returning await, and then there's sort of a pipeline of operations that happens. We just kick it off by repository.read reservations, and then you notice that we go select many, and so on. So since there's a select many method call there must be a monad in effect there. And the monad that we are using here is the async monad, or the task of t monad. So this is because repository.read reservation returns a task. So that's an asynchronous operation. Querying the database is asynchronous as it's supposed to be. And towards the end, the penultimate line there, inside that traverse, and let's not worry about what that is, it says repository create. That's still an asynchronous operation, just as it's supposed to be, because we're writing to the database. And all of this happens asynchronously because you'll notice the post method is still asynchronous. It returns a task of iAction result. So all the things that need to be asynchronous are still asynchronous. So in this way, in this sense, you're still async all the way, but the decision, the business decision, I just inject that into the asynchronous context, and that is not asynchronous because it doesn't have to be. So how do I combine dependency injection with async and await without leaky abstractions? Well, you inject the desired behavior into the async monad, which is exactly what I did. I injected that synchronous decision logic into the overall asynchronous context, and everyone is happy. It's a win-win. And we should have known this already 20 minutes ago, because we know that, how do you get the value out of my monad? Well, you don't. You inject the desired behavior into the monad. So behavior injection, not dependency injection. So if you're interested in learning more about this, on my blog, there's an article called Asynchronous Injection, which basically walks you through all the code that I've shown you here. And there's a link to GitHub repository where you can look at all the code. And I'm out of time, so I'm not going to take questions, but I'll be around at the conference, and I'll be happy to talk to you. So you can just come and ask me questions when you see me, and we can figure out anything you may have of questions in that way. So thank you all for coming, and enjoy the rest of the conference.